Dear friends, hearty welcome to the online problem solving session series organized by Maths Aspirants. Today we have the second part of the session on ordinary differential equation by Dr. Anindita Bhattacharya. Dr. Anindita Bhattacharya is currently a postdoc fellow at IIT Gandhinagar. Dr. Anindita did her UG BTech in aerospace engineering from IIT Gorakhpur, and then did her MSc Masters from ETH Zurich, Switzerland, and then PhD from IIT Gorakhpur, and now joined as a postdoc fellow in IIT Gandhinagar. So this is the second part of the session on ordinary differential equation. I would like to express my sincere gratitude to Dr. Anindita for being with Maths Aspirants. I'm sure that today's session will be really helpful for all those who are seriously preparing for different competitive examinations. I welcome everyone to this program. Welcome, Anindita.
Thank you, sir. Thank you, sir, for the very kind introduction. So last time we solved ODEs. Let's get back into solving. And so, solve this particular ODE, y square y prime plus y cube equals to sine x by x. I can write this ODE in the chat box and you can solve it, try to solve it for 2-3 minutes. And then there is the chat box. I have written the ODE in the chat box. You can try to solve it and then we will go over the solution. Has everybody been able to see the ODE? You could write in the chat message or you could reply verbally.
Yeah.
Is there any problem?
No, the question is available in the chat box.
Oh, yes. Thank you, sir.
Dear participants, feel free to respond to the questions.
So here we would use the substitution technique. We substitute z equals to y cube. So z prime equal to 3y square y prime. So this transforms it into a linear ODE. Z prime plus 3 by x z equal to 3 sine x by x square. So this can be solved by, it's a linear ODE. It can be solved by taking the integrating factor x cube, multiplying it on both sides and then integrating both sides. The next one is orthogonal trajectories. So the family is y equals to c cosec x minus cot x. Find a family y equal to c cosec x minus cot x and find a family of equations which are orthogonal to this family of equation, which is orthogonal to this equation. This equation is given in the chat box. Find a family of equations which is orthogonal to this family of equations. Has everybody written down the question? Thank you. Should I show the solution or do you want some more time? Do you want some more time or should I show the solution?
Yeah, Anindita, I think you can move with the solution.
Okay, so what we need to do is we need to eliminate C first and then find dy dx. So how we find dy dx, that will have an expression for C. Then we take the ratio and then we omit C. So once we find dy dx, we calculate dy dx new equals to -1 by dy dx old. This is the most important thing. And once you do that, you will find that the resulting trajectory, you can solve the equation yourself and check whether it is y square equal to 2 cos x plus c. If you don't find the solution, we can try and work on the detailed solution next time. Is it okay for everybody?
Yes, ma'am.
Thank you.
Yes, ma'am.
Do any of you want to show the solution? You can do that. I think sir will help you to share the slide or something, that I am not sure, but do any of you want to show the solution?
Yeah, Anindita, other participants may not be able to share their screen.
Oh, okay. So I will show the solution next week. No problem.
Yeah, sir.
Okay, sir. Thank you, sir. So let us now work on the Bernoulli equation problem. This is the Bernoulli equation. Here is. Thank you for being so understanding. This is the Bernoulli equation. Try and solve it. Has everybody looked into the question? Thank you. Should I show the solution or? Should I show the solution? Okay, thank you. I'm waiting. I'm waiting for 2 more minutes. No problem. That will be very difficult, but I will try. I will first I will show the solution, then Rohit, I will try and speak in Hindi. It will be very difficult and probably very bad. I have never tried this before, but I will try.
Yeah, and in there we have participants from different places, so it is better to proceed with English.
Sorry, sir.
We have participants from different places, so English will be more comfortable.
So I will definitely say in English, and so sorry, Rohit, then we can't speak in Hindi. Should I show the solution now? Is everybody done, or a little more time? Okay. Okay. So basically, let me see this. Yes. So first we divide by y to the power cube. And so once we will have that, we get minus y to the power minus 3y prime plus y to the power minus 2 equals to 1. Then we substitute v equals to the y to the power minus 2. Then we get v prime as a function of y prime. Then we transform the equation in the variable v. So this is the equation in the variable v that we multiply by 2 to get a better looking equation here. From here we get the integrating factor, solution, and then the solution is known. So basically first the division and the substitution is important here. Is it clear to everybody?
Yes, ma'am.
Thank you. Okay. I'm sorry, Dinesh. I did not read your message, and I showed the solution. I don't have the exact. I don't have the exact. Wait, 1y square equal to 1 c e to the power minus 2x. Let me see. One by y square e to the power minus 2x e to the power minus and I'm checking your solution. I'm copy pasting my solution and I'm seeing whether those two are equal or not. Let me copy paste first. 1 by y square, if I multiply by e to the power minus 2x, so this will be e to the power minus 2x plus no. I think there is a problem of e to the power minus 2x. Just look into my solution. I think there is a problem of e to the power minus 2x. I think you should have 1 by y square e to the power 2x equals to e to the power 2x plus c. Can you see the solution I have? Instead of minus 2x, I think you should have 2x.
Okay, ma'am.
Just check it. Let's move on to the next one.
Ma'am, when here
Sorry, what were you saying? Arun, what were you saying? I heard a voice. Somebody was saying something. Okay, I'm moving on. This is the equation next we are trying to solve. Y prime plus y sec x equals to tan x. Let's try and solve this equation. I hope everybody has noted down the question. I am waiting. Yes, yes. You can. This is linear order. This is linear first order differential equation. Rohit Kumar, this is linear first order differential equation. Tan x by tan y. No, then it will be. Then it will not be linear, right? It is linear only because it has y prime and y. If you have tan y as a function, then it will not be there. Solution Shivkant. Shivkant, I think Arun wants us to wait for a bit more. Let's wait for 1 or 2 minutes. Rohit, did you understand why tan y will make it non-linear? Thank you, Shivkant. Okay, so let me show you the solution. So this is dy dx plus pxy equals to qx. So px equals to sec x. So we calculate the integrating factor exponential px dx, exponential sec x dx. Integral of sec x equals to log of sec x plus tan x. Therefore, integrating factor is sec x plus tan x. Integration setup is multiply the OD by the integrating factor, which is sec x plus tan x on both sides, and then integrate both sides. And we use the trigonometric identity tan square x equals to sec square x minus 1, and then evaluate term by term. Sec x tan x integral is sec x, integral of sec square x is tan x, minus 1 dx is x. And step 4 of the general solution is, so y into sec x plus tan x equals to sec x plus tan x minus x plus c. So solve for y is this. And this is the simplified form. I am copy pasting this and then checking if you have the correct answers or not. Rohit, I will say it again. Just wait. I will let me copy paste the answer. So y sec x plus, yes, Arun Pratap, you are right. 1 minus x by sec x plus tan x by sec x plus tan x. I think you have some brackets missing. If not, Shivkant, you need to look into the solution. I think you have a few brackets missing. Like grouping, your solution is in grouped. If you're writing it in the way it is, I believe it is not correct. So look into the solution and see. Okay, Shivkant. And Rohit, I will say again, if I add tan y, the equation will not be linear anymore. Tan y is not a linear function of y. I like your questions, Rohit. Now let us look into this question. Wait, I did not put in the IBP. Okay. Try and wait. Yeah, try and solve this solution, this equation. It is not an IVP because there is no initial condition. Just try and solve this solution. Has everybody noted down the question?
Yes, ma'am.
Thank you. Okay, I'm pasting it once more, no problem. Dinesh. Is it okay, Dinesh, now? This is a tricky question, so you can take your time. Dinesh, did you see the question? Dinesh, should I read out the question for you? Arun, time you take. I'm talking to Dinesh. He said he was not able to read the question. Thank you, Dinesh. Do you need some more time or should I show the solution? You can write in the chat box. Do you need some more time or should I show the solution? Little more time. Okay, Dinesh. Arun, let's wait for 1 or 2 more minutes. Sir, I'm asking you, what is the best practice if some students want some more time and some students want to show the solution?
Yes, Anindita, you need to wait only for one minute. As it is an online session, they can do their own practice after the class. Okay.
Okay, sir. Yeah, let me show the solution now. Okay. Yes. So this is in the standard form of y prime. This is the linear equation. So px equals to 2 here. Integrating factor will be e to the power 2x. So multiply both sides and then and multiplying both sides, and then we will see that the right hand side cannot be integrated. This e to the power 2x by 1 plus x square cannot be integrated. So it will remain like this, and the integral term has no elementary antiderivative. This is the complete general solution. I will copy this and copy this solution and put it in the chat box. Yes, you are right, Shivkan. You can look into the solution. You cannot solve it. It will remain like this. You don't have to try anymore. You are absolutely right. The right hand side qx into integrating factor cannot be solved. Dinesh, I introduced the various kinds of equations, various kinds of solution methods, and asked to solve a few problems. I have the presentation with me. So if you want the presentation, I can share it with you. You can share me your email ID. Oh yeah, it is also available on YouTube, yes. Thank you, sir. Now I'm going to the next problem. Orthogonal trajectories. Find the orthogonal trajectory to this family of equation with parameter h. Let me write here. Thank you, sir, for sharing the YouTube link. Dinesh, you can look at it. Yes, I have shared the family of equations. The parameter is h. Find out the orthogonal trajectories to this. Has everybody noted down the equation? Thank you, thank you. Yes, Arun, I'm waiting. Yes, sir. Do you want to say something?
No.
I can't hear you, sir.
No, nothing to.
Okay, sir. Arun, is it okay if I show the solution? Arun, should I show the solution? Okay, I'm going ahead. I'm going ahead. This is, so basically we differentiate. This is the equation. We differentiate with respect to x. We get this. Then it's a simple division. You may or may not do this. That is fine. Then you group the dy dx terms and find out the slope of y prime. And then we have done one problem before. The y new should be 1 by y old, which is the orthogonality condition. Y orthogonality is minus 1 by y old, and so y orthogonality is this, and then you can integrate this to get the family of equations. So the family of equations, this is a homogeneous ODE. You substitute y equals to vx. So then dy dx becomes v plus x dv dx. Then there is a bit of algebraic manipulation. And finally, you get this x dv dx equals to h1 minus v squared by 1 plus hv. Then you do separation of variables. 1 plus hv by h1 minus v squared dv equals to 1 by x dx, and then integrate by partial fractions. Substitute back d equals to y by x, and that the solution describes the family of orthogonal curves. K is the integration constant. Is it clear to everybody? Yes, this is long. Should I keep it open for some more time? Arun, do you want me to keep it open for some more time? Show the solution for some more time? Okay. Next one, solve this homogeneous ODE y double prime plus 2y prime plus 5y equals to 0. This is a second order ODE. Try to solve this. Second order homogeneous ODE. Should I show you the solution? Okay. So basically, you will have the characteristic equation is m square plus 2m plus 5 equals to 0. Then you will calculate the roots. M, that will be equal to minus 1 plus or minus 2i. So the general solution will be yx equals to e to the power minus x, c1 cos 2x plus c2 sin 2x. And for this is, I did not ask for this, but just for your information, x tends to infinity, e to the power x will tends to 0. So and this term will tend to 0 faster than this term. So yx will also tend to 0. And is that okay? Should we move on to the next problem? Okay. Yes, solve this IVP. Here, 2y prime prime minus y prime minus y equals to 0. So second order homogeneous equation, and it has some initial conditions. Y0 equals to 1, y prime 0 equals to alpha. Has everybody noted down the equation? Has everybody noted down the equation, the question? Thank you, Arun. Thank you, Shivkant. Should I show you the solution? Or do you want some more time? My email ID is this. Yes, Archana, you'll get some more time. Shivam just wants my email ID. Okay, Arun. So the characteristic equation is 2m square minus m minus 1 equals to 0. The roots are 2m plus 1, m minus 1. These are the two factors which are equal to 0. So either m equals to 1 or minus half. So the general solution is c1 e to the power x for m equals to 1. And for m minus half, it is c2 e to the power minus x by 2. The derivative is y prime x is c1 e to the power x minus 0.5 c2 e to the power minus 0.5 x. So at x equals to 0, y equals to 1. So c1 plus c2 equals to 1. At x equals to 0, y prime equals to alpha. So c1 minus half c2 equals to alpha. Then we solve for the constants c1 and c2 in terms of alpha. And then you finally get yx like this. I will copy it and paste it in the chat. Indumati, let me paste it, then I will see whether it is okay. 1 plus 2 alpha by 3 to the power x plus 2 minus 2 alpha, that's fine, by 3 e to the power minus, absolutely correct, Indumati. Yes, and then you need to put in the initial conditions. You have to find the values of C1 and C2 in terms of alpha. I'm moving to the next problem. This is very interesting. This is the Cauchy-Euler problem. You can try for some time, then I will take some time to explain this. Try and solve this equation. Thank you, Archana. Okay, so basically what you need to do is, should I show you the solution or should I wait for some more time? Arun, this is a difficult question. Don't worry. Should I show you the solution? Everybody? Okay, I'm going ahead. I'm showing this. Okay, Indumati. Okay, Indumati. Arun, let's wait for one or 2 minutes. Okay, I'm going ahead with the solution. So this is a Cauchy-Euler solution. We assume the solution of the form y equals to x to the power m. So these are the derivatives. This is easy to understand. Y, y prime, y double prime. So you will notice something. Y is x to the power m, y prime is x to the power m minus 1, y double prime is x to the power m minus 2. Now, if I multiply y prime by x, it becomes x to the power m, and this by x squared, it becomes x to the power m also. So, we substitute into the equation and simplify to get this. Now, this is very interesting because this does not depend on x. So, this is why we took y equals to x to the power m. Suppose we took y equals to e to the power x, you can see that here that the condition will depend upon x, and it will not be valid for all x. So in that case, m will not be a constant, and in that case, the derivative terms that we took here will not be valid anymore because we assumed m is a constant here. So that is why x to the power m is a wonderful solution. And then we solve this characteristic equation, and we get the roots. So if the discriminant is more than 0, we get the real distinct roots. If it is equals to 0, we get real repeated roots. And if it is less than 0, we get complex roots. So then we get, this is the summary of the general solutions. The first one is easy, C1 x to the power m1 plus C2 x to the power m2. m1 and m2 are different. So case 2, when both are m, then we use a term log x here. Why we use that term? Let me show it to you here. It's pretty long. So if the discriminant is 0, m1 equals to m2 equals to m. So one solution is x to the power m. So if we try another one, c x to the power m, it is the same function as 1. We lack a second direction because say one is c x to the power m, the other is, let's say, c1 x to the power m, the other two is c2 x to the power m. If we add them, we get c1 plus c2 x to the power m. That is nothing but k x to the power m, which is not an independent solution. So what we do is we assume the second solution is y2 equals to a function of ux, which is not a constant, times u1. So ux times x to the power n. So we substitute y2 into the original ODE. Terms containing u cancel because y1 is a solution. We get this condition x times u double prime plus u prime equals to 0. So you can sort of do some algebraic manipulation and finally find that ux is of that form log x. This is why the second term we have a form log x here. And for the final thing, discriminant less than 0, I'm going to show you the solution. So this is the characteristic equation. So m equals to lambda plus I omega. So lambda is the real part, that will be 1 minus alpha by 2. Omega is the imaginary part, which is given by this. So the base solution is y equals to x to the power lambda plus minus I omega. Now x to the power I omega can be written as e to the power I omega ln x. Then we use the Euler identity. E to the power I theta is cos theta plus I sin theta. Substitute theta is as omega times ln x. So e to the power I omega ln x is cos omega ln x plus I sin omega ln x. And finally, you get this general solution that I have written out here. So I will write this the general solution for these 3 cases in the chat box. Indumati, the first solution is right for discriminant more than 0. If the discriminant is not more equal to 0 or less than 0, you have case 2 and case 3. I have typed the solution. You can take a look at it, and basically the physical interpretation is this x to the power lambda is an envelope. It's the amplitude, and omega ln x is the frequency. that is the number of times it crosses the x-axis. The y-x crosses the x-axis. And the distance between two is the frequency, and the log x term stretches the waves as x increases. Let me know if you have any questions for why d equals to 0, you get the log x term, or d less than 0, you get this term. Let me know. Okay. So I will finally go on to the next problem. This is very easy. dy dx plus y equals to okay, this is actually not very easy. So you can copy the solution, copy the question, and try it at home. I can copy paste the solution. We can discuss the solution next time. That is a question I will not be able to say because I haven't looked into all IIT JAM papers. I think sir might be able to help. Sir, Arun has a question.
Yeah, I have seen it. The syllabus is given in the website of JAM, and we will try to arrange more sessions on ODE which cover the topics from all the portions. We already have conducted many sessions, so I am not able to give any specific directions for that now. We will try to give some more sessions which gives more insight to the area.
Thank you, sir.
And also, see, we cannot predict anything about the examination. The questions may be from any part of the syllabus. Actually, the syllabus of JAM is comparatively very less, so it is always advisable to cover all the area given in the syllabus and try more and more problems. So, Anindita, is the topic for today's session over?
Yes, sir. This is the last. This is the last one. Let me just type out the solution. I will show this detailed solution next week.
Okay. They can try also.
Yes, sir. The topic for today's session is over.
Thank you, Anindita, for today's session. And dear participants, now it is your turn to share your feedback or share your comments. Please feel free to share your opinions.
Thank you, Indumati.
Hello, ma'am.
Yeah.
Yes, Archana.
Ma'am, yes, I'm Archana. I've completed my BSc, ma'am. I have actually
I couldn't hear you. You have completed your
BSc.
okay.
Yeah, ma'am. I have attended JAM, but I just wanted to connect back to the classes after JAM. I haven't studied, so I really enjoyed your session. And if possible, ma'am, could you give more type of questions of ODE? Like
Sure, Archana. I will try. I will come back with some of the solutions that I did not have today, and I will come back with more problems.
Yes, ma'am. Sure, ma'am. Thank you, ma'am. Ma'am, your explanation was nice, ma'am. Like crisp and
Thank you,
clear.
Archana. Thank you, Archana.
Oh, yes, ma'am. Thank you, ma'am.
Thank you, Archana. Others? So if any of you would like to share a feedback, you can make it now. Otherwise, you can comment in the chat box as well. Okay. Thank you, Anindita. I think we can wind up today's session here.
Okay, sir.
Thank you. Thank you, everyone. Let us wind up here.
Okay.
Bye.
Bye.